We're talking about exponential functions, but before we do that, we have to talk about what the laws of exponents are. So first of all, I want to define some things. I have m, n, a, and b, and they're all real numbers, and a is greater than 0, and b is greater than 0. So if I have all those, then I can write these laws. First of all, I know that a to the m times a to the n is the same as a to the m plus n. So if they have the same base, I multiply, I can add. A to the m raised to the n is the same as a to the mn. So when I raise an exponent to a power, I multiply the exponents. If I have a product and I raise it to the mth, that's the same as a to the m times b to the m. I can distribute that exponent to each piece. No matter what m is, when I raise 1 to any exponent, it always equals 1. And no matter what my base is, if I raise it to the 0, it's always 1. If I have a negative exponent, a to the negative m, that's the same as 1 over a to the m. Or I can write it as 1 over a, the whole thing to the mth power. And so to expand on that, if I have a over b to the negative m, it's the same as b over a to the m. So really what the negative exponent is doing is it's giving you a reciprocal, or making you take the reciprocal. So now that I've given you the laws, we can actually define an exponential function. So exponential function would say a function of the form f of x equals c a to the x, where a is greater than 0, a is not 1, and c is not 0. That's my exponential function. A is called the growth factor, how it grows, and c is called the initial value. Initial because if x is 0, right, then a to the 0 is 1, so it's just going to equal c.